can you solve this geometry challenge? Here's the question. Given this quarter circle, let's draw a chord like this. And let's draw a segment that is perpendicular to this chord. Now, this segment measures 3 units. And from this point to this point, this is 4 units. And let R be the radius of this quarter circle. And the question is, what is the length of the radius of this quarter circle? Now, pause this video right now and see if you can answer this question, because I will show you the answer and the solution in 3, 2, 1. Alright, the length of this radius simply equal to 25 times square root of 2 divided by 2, and that is the answer to this question. And in this video, I will show you 4 different approach or 4 different methods to find the value of this radius. So here's the 4 solution. The first one is we will use the Stewart theorem. The second is the cosine law. The third, we use the triangle's area. And the fourth one is the similar triangles, which is the most convenient way to solve this kind of question. Now let's begin with the Stewart theorem. Now, what is Stewart theorem? So this is the Stewart theorem. And the easiest way to remember the Stewart theorem is using these mnemonics. So man plus dad equals bomb plus sink, wherein all of these variables are the side length inside this triangle. Now, in order to use the Stewart theorem, take note, this is a 45, 45, 90 right triangle. In short, if we extend this segment measures 3 units, we also created a 45, 45, 90 right triangle. Now, since this is 4, the other side is also 4. And the hypotenuse must be equal to 4 times square root of 2. Now, since the whole thing is the radius of this quarter circle, therefore, this small segment measures r minus 4 times square root of 2. And in order to use the Stewart theorem, we need a triangle. So from this point, let's connect this to this point like this. And we have a 3, 4, 5 right triangle. One final segment, and we can now use the Stewart theorem. So what is that segment? This is the radius of this quarter circle. And let's call this as r. And now, using the concept of Stewart theorem to our figure, we can say that 4 square root of 2 times r minus 4 times square root of 2 plus 7 times r times 7 equals r times 4 square root of 2 times r plus 5 times r minus 4 times square root of 2 times 5. This is exactly this mnemonics, man plus dad equals bomb plus sink. So now let's focus on this equation and let's simplify and find the value of r. If we simplify this, we get this equation. Now this is just an algebra, so simplify and we get negative 8r equals negative 100 times square root of 2. And to find the value of r, divide both sides by negative 8 and simplify, and sure enough, you get r equals 25 times square root of 2 divided by 2. And that is the length of the radius of this quarter circle. So this is our first solution. Now, how about the second solution using the cosine law? And this is the cosine law. Now, in order to use the cosine law, we need a triangle. So from this point, let's have a triangle like this. Now, we know the length of this segment. This is just 5 units. And also, we know the length of this chord. This is just r times square root of 2 because we have a 45, 45, 90 right triangle. Now, since this is r times square root of 2 and this is 4, this part must be equal to r times square root of 2 minus 4. Now, using this right triangle, we can now find the hypotenuse. Using Pythagorean theorem, we get that the hypotenuse simply equal to square root of 9 plus quantity r times square root of 2 minus 4 raised to the power of 2. This is the length of the hypotenuse of this right triangle. And we need an included angle. Now, what is the measure of this angle? This intercepts 270 degrees of the whole circle. In short, this angle must be equal to 270 degrees divided by 2 or simply equal to 135 degrees. And we can now use the cosine law. So using the cosine law, we have this equation. So we have r times square root of 2 raised to the power of 2 equals 5 squared plus this hypotenuse raised to the power of 2 minus 2 times 5 times this length times cosine of 135. And of course, this is simply the cosine law. Now, let's focus to this equation and let's solve for the value of r. If we simplify this, we get this result. And take note that cosine 135 degrees simply equal to negative square root of 2 over 2. Now, simplify more. This is just an algebra. And simplify this equation. You arrive at this equation 28r squared minus 400 times r times square root of 2 plus 1250 equals 0. And we can factor this out nicely as 2r minus 25 square root of 2 multiplied by 14r minus 25 times square root of 2. Now, to solve for the value of r, we will use the zero property. Since the product is equal to 0, at least one of them must be equal to 0. So, if we equate these factors into 0, we get that r equals 25 times square root of 2 over 2, and the other one is 25 times square root of 2 all over 14. Now, 25 times square root of 2 over 2 is approximately equal to 17.68. And 25 times square root of 2 divided by 14 is approximately 2.53. Now, technically speaking, the radius of this quarter circle cannot be less than 4. Therefore, we can reject this value, 2.53. In short, our answer is this 17.68 or simply equal to 25 times square root of 2 divided by 2. And again, we get the same result. So this is our second solution using the cosine law. Now, how about the third solution using the triangle's area? So let's begin. And also, we will use this figure a while ago. Now, in order to find the triangle's area, we have two possible formula. So the first one is 1/2 base times height. So to find the area of this red triangle, the height is 3 and the base is r times square root of 2. So the area is just 1/2 times r times square root of 2 times 3. Also, since we can say that this red triangle is inside the circle, we can use this formula. So the formula to find the area of this triangle simply equal to the product of the side of the triangle divided by 4 times r. Just switch the position of this radius and the area of the triangle. And using this formula, we can say that the area of this triangle is equal to 5 times r times square root of 2 times this side or the side length of this red triangle divided by 4 times r. Now, since these two equations is equivalent to the area of the triangle, we can set them equal to. And of course, using this equation, we can now solve for the value of r. So simplify this equation, we arrive at this equation. Now simplify more, we arrive at this equation 14r squared minus 200 r times square root of 2 plus 625. Now multiply this by 2. We arrive at 28r squared minus 400r times square root of 2 plus 1250. This is very familiar because this is the equation that we use on the second solution using the cosine law. In short, using this equation, we can get the value of r as 25 times square root of 2 divided by 2. And again, this is our answer to the question. So this is our solution number 3. And now let's have the fourth solution. And of course, if you have another solution, feel free to write your solution in the comment section down below. So in order to use the similar triangle, what we're going to do is to create a triangle, of course. So from this point, let's extend this and create a right triangle like this. And let's connect these 2 points. Now, what we know in this figure, we know this angle, this is 135 degrees. And straight angle is 180 degrees. In short, this angle right over here simply equal to 45 degrees. Now, since this is a right triangle, the other angle is 45 degrees. So this is a 45, 45, 90 right triangle. Now, what we know, this length is 5 units, and the length of this chord is simply equal to r times square root of 2. Now, let's call this side b equal to x. And let's name some important points. So let's name this point as A, this is B, this is C, this is D, this is E. Now, we have a common angle of angle A. In short, we can say that triangle ABC is similar to triangle ADE. Now, since they are similar, the ratio of their side must be the same. So we can set that AB over BC equals AD over DE. Now, AB is 4, BC is 3, AD is x plus 5, and DE is x. Solve for x, and we get that x equals 15. So we know the value of this x is 15 units. Now, using the big right triangle and using Pythagorean theorem to triangle ADE, we can now solve for the value of this radius r. So we have r times square root of 2 raised to the power of 2 equals 15 squared plus 20 squared. And recall that we have 15, 20, 25 right triangle. In short, this r times square root of 2 squared simply equal to 25 squared, which is r times square root of 2 equals 25, and r equals 25 times square root of 2 divided by 2. And we reach again this value of r. Therefore, using 4 different solutions, 4 different methods to find the value of r, and our answer to this question is 25 times square root of 2 divided by 2. And as always, we are done.